In this video, we'll learn what cloud is, what virtualization is and its applications, bring your own device policy, and security testing and its role. We'll begin with the concept of virtualization. Virtualization is a process that allows for more efficient utilization of computer hardware, and it's the foundation of cloud computing. Now, what is this virtualization? It is a technology that allows you to run multiple operating systems side by side. By using the same hardware, you'll be able to run different operating systems using the same computer hardware. Virtualization is the foundation of cloud technology. Hypervisor. A hypervisor, also known as a virtual machine monitor or VMM in short, it's the software that creates and runs the virtual machines. A hypervisor allows one host computer to support multiple guest VMs by virtually sharing its resources, such as memory and processing. Hypervisors make it possible to use more of systems' available resources and provide greater IT mobility, since the guest VMs are independent of the host hardware. Let's say you have a computer with 16 gigs memory RAM and it has 8 processors. And right now about 3 of them are in use and about 4 GB memory is in use. With the rest, using a hypervisor, you could run an Ubuntu operating system if need be. Since hypervisors make it possible to use more of a system's available resources, this means that they can be easily moved between different servers because multiple virtual machines can run and operate on a single physical server with a hypervisor. It reduces the requirement for space, energy, and maintenance. To summarize, the hypervisor drives the concept of virtualization by allowing the physical host machine to operate multiple virtual machines as guests. Cloud computing. It's the use of remote servers on the internet in order to store, manage, and process the data instead of using a physical or local on-site computer server. You'll upload this data and process it on a cloud, and this cloud, it's on the internet. Simply put, cloud computing is the delivery of computing services such as servers, storage, databases, networking, software, analytics, and intelligence over the internet. Features of cloud computing. You'll be able to avail remote services. You'll have cloud backups. You'll be able to run virtual desktops or applications. You'll be able to host web applications. You can increase the storage whenever you want. Rapid elasticity. Cloud computing also provides you the on-demand access. Benefits of cloud computing. First, we'll begin with the cost. Cloud computing eliminates the need for buying hardware and software and setting it up and running it on local data centers. You'll be able to save a lot of money. Speed. Most cloud computing services are provided self-service and on-demand, so even vast amounts of computing resources can be provisioned in minutes, giving your business a lot of flexibility and taking the pressure off capacity planning. You could upgrade your plan within minutes instead of spending a lot of money and time on setting up the IT infrastructure. Performance. The biggest cloud computing services run on a worldwide network of secure data centers, and they are regularly upgraded to the latest generation of fast and efficient computing hardware. This offers several benefits over a single corporate data center, including reduced network latency for applications and greater economies of scale. Productivity. On-site data centers typically require a lot of racking and stacking, hardware setup, software patching, and other time-consuming IT management chores. With cloud computing, it removes the need for many of these tasks, so IT teams can spend time on achieving more important business goals. Software patching, hardware setup, it's all the worry of the cloud service provider now. Reliability. Cloud computing makes data backup, disaster recovery, and business continuity easier and less expensive because data can be mirrored at multiple redundant sites on the cloud service provider's network. Security. Many cloud providers offer a broad set of policies, technologies, and security controls that strengthen your overall security posture. helping protect your data, applications, infrastructure from potential threat actors. Lastly, the global scale. Benefits of cloud computing services include the ability to scale elastically in cloud speed. From the cloud service provider's perspective, that means delivering the right amount of IT resources right when they are needed. Moving on, there's different types of cloud computing. Based on your need, it can be classified as follows: public cloud, private cloud, and hybrid cloud. Firstly, we'll be discussing this public cloud. Public clouds are owned and operated by third-party cloud service providers, which deliver their computing resources, like servers and storage, over the internet. Microsoft Azure is an example of a public cloud. With a public cloud, all hardware, software, and other supporting infrastructure, it is owned and managed by the cloud provider. You access these services and manage your account using a web browser. Whereas in a private cloud, it refers to a cloud computing resources used exclusively by a single business or an organization. A private cloud can be physically located on the company's on-site data center. Some companies also pay third-party service providers to host their private cloud. A private cloud is one in which services and infrastructure are maintained on a private network. Only the organization can access the private cloud. It's not public. Differences between the public cloud and private cloud. In public cloud, the virtualized resources are publicly shared, whereas in a private cloud, only the organization can access it. A public cloud supports multiple customers, whereas a private cloud only has a handful of dedicated customers. Public cloud supports connectivity all over the internet, whereas a private cloud supports connectivity over private networks only. Public clouds are suited for less confidential information, whereas if you want to keep things more private and confidential, a private cloud is more suited for it. Now we'll be discussing about the hybrid cloud. It's the best of both. Hybrid clouds combine public and private clouds bound together by the technology, which allows this public cloud and private cloud to share data and applications between them. By allowing data and applications to move between private and public clouds, from and to private and public clouds, a hybrid cloud gives your business greater flexibility, more development options, and helps you optimize your existing infrastructure, security, and compliance requirements. Now we'll be discussing about the different types of cloud services that are offered. Firstly, we'll be beginning with the infrastructure as a service. This is the most basic category of cloud computing services. With this, you rent IT infrastructure, that is the servers and virtual machines, storage, network, operating systems. You rent it from a cloud provider and you pay it on a subscription basis, on a pay-as-you-go basis. Software as a service. It's a method for delivering software applications over the internet, on demand, and typically on a subscription basis. Users connect to the application over the internet, usually with a web browser on their phone, tablet, or PC. Google Stadia is an example of software as service. Google Stadia, it allows you to play games on their server. You simply connect to their servers and then you get to play the video game. And then lastly, platform as a service. Platform as a service refers to cloud computing services that supply an on-demand environment for developing, testing, delivering, and managing software applications. This is designed to make it easier for developers to quickly create web or mobile applications without worrying about setting up or managing the underlying infrastructure of servers, storage, network, and databases needed for the development process. Platform as a service is useful for developers. Moving on, we'll be discussing the Bring Your Own Device policy. BYOD refers to the policy of allowing the employees in an organization to bring their own devices to workplace, such as laptops, smartphones, and tablets. Mobile device management. When a policy such as BYOD is in place, it's important to keep track of devices to minimize security risks. The use of such security software by IT department to monitor, manage, and secure the employee devices. This process is called as mobile device management. IoT, Internet of Things. Internet of Things is the network of devices that connect, interact, and exchange data between the devices to collect information and generate insights. What is Internet of Things and how can it help your business? IoT enables your organization to analyze and act on data. It allows you to make smart decisions in real time with a timely and relevant insights about your business and customers that come with this new sources of data. There's a lot of potential for all kinds of industries, ranging from manufacturing, transportation, energy, agriculture, retail, and government, to operate more efficiently and provide new value to customers by implementing the right Internet of Things solution, IoT solution. IoT security challenges. Firstly, there's the problem of insufficient testing, and it's vulnerable to brute forcing attacks. It's more prone to malware and ransomware, and there's data security and privacy concerns. Now we'll be discussing the security testing. First, the vulnerability scanning. What is vulnerability scanning? It's the process of inspecting systems and networks for vulnerabilities or weaknesses, which can be taken advantage of by threat actors to disrupt and take control of IT infrastructure. Specialized tools or softwares known as vulnerability scanners are used to help administrators find and address vulnerabilities. Vulnerability scanning is a never-ending and ongoing process. These scans have to be conducted periodically. Now, what are the goals of vulnerability scanning? Firstly, it's to identify the vulnerability. Then it's to identify the potential lack of security controls, and then to identify the common misconfiguration. The idea is to reduce the attack surface. Moving on, penetration testing. In penetration testing, the pen testers or ethical hackers are tasked by an organization to try and hack into their IT infrastructure. Now, why do that? The goal of pen testing is to find vulnerabilities and reduce the attack surface in order to protect the IT assets. There's three types of pen testing. Firstly, there's the black box testing, white box testing, and gray box testing. Black box testing. In this scenario, the pen tester has zero knowledge of the organization's security policies, controls in place, and the IT infrastructure. The pen tester has to gather info on the organization, and the pen tester should come up with a plan to hack and exploit the IT infrastructure. This testing simulates an attack from an external threat actors. In this scenario, since the pen tester doesn't know much, he has to gather as much information as he can, and it includes a lot of trial and error. Whereas in white box testing, the pen tester has complete knowledge of organization's security policies, controls, and IT infrastructure. Since the pen tester has access to this information, the pen tester can devise a more tailored approach to hack into their systems. Here there isn't much of a trial and error since the pen tester is aware of the security controls and policies. He'll be able to come up with a more organization specific attack. This testing simulates an insider attack. Gray box testing. In this scenario, the pen tester has some knowledge of the organization, but not complete information about the gray box testing. Now we'll be discussing about the security audits. It's the systematic review of security policies and controls in place. The purpose of this review is to test the effectiveness of the security measures in place. The goal of a security auditor is to provide an impartial and unbiased review of the security controls and policies in place. Now there's two types of security audits: internal audit and external audit. Internal audit is performed by the organization's internal staff or employees. Internal security audit is only intended for the view of authorized organization personnel, whereas an external audit is performed by third-party auditors. External audit reports are more impartial and unbiased than the internal security audits.